This Buick looks American. The badge is American. The company behind it is American. And for more than a century, the engineering story behind a car like this would have led you back to Detroit. But not this time. The Buick Electra E7 was developed through General Motors China operation with SAIC at the Pan-Asia Technical Automotive Center in Shanghai. And when it went on sale, more than 10,000 were sold in its first month. That alone would be interesting. But then General Motors did something much bigger. In August 2026, GM signed up for another 20 years with its Chinese partner, SAIC, extending their joint venture through 2047, and said more vehicle development work would be done in China, not just manufacturing, development. Then GM confirmed that China-developed Buick Electra models would be exported from China to markets around the world. And there is an even crazier possibility waiting behind all of this. Reuters reported that a future Cadillac Optiq could potentially move away from GM's Detroit-developed Ultium architecture and onto technology developed through GM's China operation. GM has pushed back on that Cadillac report and called it speculative, so we are not going to pretend it is confirmed. But think about what we are even discussing here. 20 years ago, American engineers went to China to teach the country how to build world-class cars. In 2026, one of America's biggest automakers is openly moving more development responsibility in the opposite direction. And to understand how insane that reversal is, you have to remember what China used to be to Western automakers. For decades, the basic formula was simple. Detroit, Wolfsburg, Paris, or Stuttgart designed the car. The foreign company controlled the technology, the platform, the powertrain, and most of the important engineering decisions. China offered factories, workers, suppliers, scale, and access to an enormous market. Western companies brought the knowledge. China absorbed it. That arrangement helped companies like Volkswagen, General Motors, and others sell millions of cars in China, while the local industry learned incredibly quickly. But somewhere between the rise of electric vehicles, batteries, software-defined cars, assisted driving, and the smartphone-style technology race, that relationship began changing. China did not stop being a manufacturing powerhouse. It added something far more threatening, an engineering ecosystem that can develop new automotive technology at a speed many traditional manufacturers are struggling to match. Reuters now describes China not simply as the factory for legacy automakers, but increasingly as an innovation engine for them. And the car sitting in the middle of this reversal is almost comically appropriate, a Buick. Few badges feel more connected to traditional American automotive history, yet the new Electra E7 is exactly the kind of product GM needed China to help it create. This was not an American vehicle shipped to Shanghai and given different headlights. Reuters reported that the E7 was developed entirely through SAIC GM's technical operation in China. That matters because it means the Chinese team was not simply localizing somebody else's homework, it was doing the homework. Then customers responded. More than 10,000 E7s were sold in its first month, a rare success for a foreign automaker in a Chinese market that has become brutal for legacy brands. This is the moment where the story stops being about patriotism, flags, or who copied whom. GM had a business problem, its Chinese operation produced a car that worked, and when something works in the car business, everybody in the company starts paying attention. But sales are only the first shock. Underneath the E7 sits something called the Xiaoyao architecture, developed through PATAC, the Shanghai Technical Organization run by GM and SAIC. This is where the story gets much more serious, because a modern vehicle platform is no longer just a metal floor with suspension mounting points. The architecture has to connect propulsion, chassis control, smart cabin technology, computing, driver assistance, charging, and software. Reuters highlighted capabilities including a 900-volt electrical system as an example of how GM's Chinese operation is trying to compete with the fastest-moving EV companies around it. And that tells you what GM is actually buying with this partnership. Cheap labor is not the interesting part anymore. The interesting part is speed, integration, suppliers, software, battery technology, electronics, the ability to look at what BYD, XPeng, NIO, Geely, Huawei, and Xiaomi are doing this year and build something competitive before the benchmark changes again next year. Now stop here, because the next part is where this goes from interesting Chinese Buick to a global story. The E7 is not meant to remain trapped inside China. GM says the renewed SAIC GM agreement allows Buick and Cadillac vehicles made in China to be shipped to the Middle East, Africa, South America, Mexico, and other Asian markets, beginning with exports of the China-developed Buick Electra series later in 2026. Think about that flow of technology for a second. The traditional model was Detroit to Shanghai. America develops it, China builds it. This model can increasingly become Shanghai to the world. Develop it in China, manufacture it there, put an American badge on the nose, then ship it to customers across multiple continents. China is no longer simply where GM goes to make cars for Chinese people. China is becoming one of the places GM can develop cars for people who do not live in China at all. And then comes Cadillac. This is the part where you should pay attention very carefully because there is a difference between a report and a confirmed product plan. Reuters reported that GM was considering the China-developed Xiaoyao architecture for a future Cadillac Optiq, potentially replacing the Detroit-developed Ultium foundation associated with the current generation. GM later said, reporting about the Optiq was speculative. So no, we cannot say a Chinese platform Cadillac Optiq is definitely coming. But the disagreement itself is almost more interesting than a confirmed specification. A serious conversation now exists around whether one of Cadillac's future EVs could use architecture created through Shanghai rather than relying entirely on the EV foundation developed in Detroit. A Cadillac, not a cheap export model, not some anonymous joint venture brand. Cadillac. Even being able to say that sentence without it sounding absurd tells you how much the balance has changed. And just when this starts sounding like America is packing Detroit into shipping containers and sending everything to Shanghai, there is another twist. It is not. In fact, for cars actually sold in the United States, political pressure is pushing some manufacturing in the opposite direction. Ford has announced plans to move production of some Lincoln models from China to the United States beginning in 2030. GM plans to move Buick and Vision production from China to the U.S. starting in 2028. Tariffs on China-built vehicles are high, and U.S. connected vehicle regulations restrict certain Chinese hardware and software. So physically, some American market cars are becoming less Chinese. But technologically, legacy manufacturers can simultaneously become more influenced by what their Chinese engineering teams and partners are learning. That is the weird contradiction at the center of this entire story. The factories can move apart, while the engineering ideas move closer together. And if this were only happening at General Motors, you could call it one company making a desperate move. It is not. Look at Volkswagen. Volkswagen Group China, CARIAD China, and XPeng have jointly developed the China Electronic Architecture, or CEA. This is the electronic backbone Volkswagen intends to use for locally produced electric vehicles in China. Volkswagen says the architecture can reduce the number of electronic control units by roughly 30% compared with the previous generation, while supporting functions such as AI-based cockpits, advanced driver assistance, and over-the-air software updates. In January 2026, Volkswagen announced production of its first locally developed zonal electronic architecture. Then, in March, the first vehicle developed through its expanded cooperation with XPeng rolled off the production line. Read that sentence again. Volkswagen, one of the companies that taught the modern world how to mass-produce sophisticated cars, is now using XPeng as a long-term technology partner to move faster. And that is not an insult to Volkswagen engineering. It is actually more revealing than that. Volkswagen knows exactly how difficult building a car is. It also knows the traditional automotive development process was designed for a world where a vehicle could remain technologically competitive for years. That world is disappearing. Today, a cockpit can look old before the facelift arrives. Driver assistance hardware can become obsolete halfway through a development cycle. Charging performance that looked incredible 3 years ago can become an embarrassment when a competitor launches something twice as fast. Software expectations come from phones now, not from old cars. Volkswagen is not suddenly unable to engineer a suspension system. The problem is that China has turned vehicle development into a technology race where standing still for 2 years can feel like standing still for 10. And Renault gives us perhaps the strangest proof of all, because the vehicle in question is not even primarily a Chinese market car. The new electric Renault Twingo is for Europe. It is assembled in Europe. It is supposed to be an affordable European city car, wearing one of France's most recognizable automotive badges. Yet Renault itself says a major phase of the program took place at its Advanced China Development Center in Shanghai, created in 2024. Around 100 engineers there worked on systems integration and project management. Renault specifically points to China's rapid development times, competitive costs, and technological expertise as reasons the project could accelerate. Let that sink in. A French company used an engineering center in Shanghai to help speed up development of a French car for Europeans. China is no longer just exporting EVs. In a quieter way, it is beginning to export the development process itself. And this might be the most dangerous advantage China has built because it cannot be photographed for a thumbnail. Speed. Traditional automotive companies spent decades creating incredibly rigorous development structures. That gave us cars that could survive winters, deserts, crashes, potholes, and hundreds of thousands of kilometers. But those same companies now have to combine that rigor with an industry that increasingly behaves like consumer electronics. Chinese manufacturers have been forced to survive in a market where a competitor can reveal a new battery, a new assisted driving system, a new charging architecture, a new smart cabin feature, or an entirely new model before your own facelift reaches the showroom. Every company operating there either learns to move faster or watches the market move without it. Renault did not go to Shanghai because French engineers forgot how to make a hatchback. It went there because Shanghai had become one of the places where automotive development had learned how to move at a completely different pace. Then Audi takes the entire story one step further and makes it visually obvious. In China, Audi created a new electric brand named simply Audi in capital letters, and the cars do not even wear the traditional four-ring badge. The first model, the E5 Sportback, came from cooperation between Audi and SAIC, combining Audi engineering with technology from China's digital ecosystem. And Audi did not treat this as a one-car experiment. In April 2026, Audi and SAIC announced an even deeper partnership for future models, including a new innovation and technology center in Shanghai. The E5 Sportback went on to win the 2026 China Car of the Year award. Just imagine showing this strategy to an Audi board meeting from 20 years ago. Build a separate electric Audi identity in China. Work deeply with SAIC. Use the Chinese digital ecosystem. Remove the four rings from the product, and then expand the partnership because the first car worked. It sounds less like localization and more like the creation of an entirely new branch of Audi's engineering culture. So what happened? Why are companies with a century of automotive experience suddenly looking toward an industry that was once accused of simply copying them? The answer is uncomfortable. China changed the definition of what makes a car advanced. Mechanical engineering still matters. Crash safety still matters. Ride, handling, durability, and manufacturing quality still matter. But now, the competitive battlefield also includes battery chemistry, high-voltage electrical systems, silicon, centralized computing, LiDAR, cameras, AI, driver assistance, voice assistants, operating systems, cabin displays, app ecosystems, charging networks, over-the-air updates, and software features that can change after the owner takes the car home. China spent years building an enormous electronics and battery supply chain. Then that ecosystem collided with the car industry. The result was not simply a cheaper electric car, it was a different way of developing cars. And actually, all this talk about cars becoming computers brings up something useful for your own car. If a check engine light ever comes on, a tool like the Blue Driver OBD2 scanner can connect to your phone and show you what your car is actually reporting before you head to a repair shop. It works with many vehicles sold in North America from 1996 onward. I've linked it below if you want to check it out. Now, back to China. And the companies competing inside China have made that environment vicious. BYD can build batteries, electronics, and vehicles at enormous scale. Geely operates everything from mainstream brands to luxury EV companies. Huawei can walk into a car project with sensors, computing, software, and a complete smart cabin ecosystem. XPeng treats software and assisted driving as central parts of the vehicle. NIO built battery swapping into the ownership model itself. Xiaomi entered the industry carrying the mentality and customer expectations of a consumer technology company. Every time one company moves, the others are forced to react, and that means a foreign automaker cannot simply arrive with a famous badge, slightly redesign a global model, and assume customers will wait in line. The badge still has value, but the technology has to earn attention every single year. That creates a nightmare for legacy automakers. Imagine starting a 5-year development program with the best infotainment system you have ever built. 2 years later, the Chinese market has moved to a different type of interface. Imagine designing a perfectly competitive 400-volt EV, only for 800-volt systems to begin moving down market before your car launches. Imagine spending years perfecting an electronic architecture while local competitors reduce hardware complexity, centralize computing, and push software updates every few weeks. Your car can be excellent and still look old on the day it arrives. That is the threat. China does not need every local car to be better than every Western car. It only needs the competitive cycle to move fast enough that traditional development processes become a disadvantage. And now we reach the part that may matter outside China even more than the cars themselves. GM is turning China into an export base for China-developed Buick products. Renault is using a Shanghai engineering center on European programs. Volkswagen is developing electronic architecture with XPeng. Audi and SAIC are building an entire technology partnership around locally developed electric cars. These are not four identical strategies. They are not evidence that China controls Western automakers, but taken together, they show something that would have been difficult to imagine 20 years ago. The flow of automotive knowledge is now genuinely two-way. Western companies are still bringing decades of safety engineering, manufacturing expertise, brand knowledge, and global standards into China. But they are also taking Chinese development speed, software thinking, electronics integration, and local technology partnerships back into their own organizations. And there is a delicious irony hiding inside General Motors' new 20-year deal. SAIC GM was founded in 1997, during an era when joint ventures were one of the primary ways China gained access to the global automotive industry. Western companies entered the market with technology and brands. Chinese partners gained experience working with them. Almost 30 years later, GM has now renewed that same relationship through 2047 after restructuring its China business, and the company is talking about more development work in China and using China as an export hub. The partnership did not disappear when China learned how to build cars. Its purpose evolved. China is no longer valuable only because it can manufacture GM products. It is increasingly valuable because it can help GM figure out what the next generation of those products should be. But do not mistake any of this for an easy Chinese victory lap. The same environment that made China so good at developing cars is brutally unforgiving. Domestic competition is savage. Prices can collapse. New brands can disappear. Technology spending is enormous. Political tensions can block Chinese hardware from Western markets. Tariffs can destroy the economics of exporting a car overnight. Companies like GM, Volkswagen, and Audi are therefore trying to do something incredibly difficult: absorb the advantages of China's automotive ecosystem without becoming dependent on technology they cannot legally or politically use everywhere. That may be the defining engineering challenge of the next decade. Build globally, learn locally, share what can be shared, isolate what regulations demand, and somehow still make money. Which brings us back to the title. America just moved its car future to China. Taken literally, that would be an exaggeration. Detroit has not closed. GM has not abandoned American engineering. Cadillac is not suddenly a Chinese company. And Chinese-developed vehicles face serious barriers to entering the United States. But as a description of the direction the industry is moving, the title points at something very real. One of America's largest automakers has committed to another 20 years with SAIC. It says more development will happen in China. A China-developed Buick is being prepared for international export. Volkswagen is building electronic architecture with XPeng. Renault used Shanghai to help create a European Twingo. Audi is expanding its engineering relationship with SAIC. The future did not move to one country. The center of gravity became more complicated, and maybe that is the most important change of all. For most of the modern Chinese car industry's history, everybody asked the same question: how quickly can China catch the West? Every new Chinese car was judged by how close it came to Toyota, Volkswagen, BMW, Mercedes, Cadillac, or Tesla. Could China match their quality? Could it match their engines? Could it match their safety? Could it design something original? Could it build a global brand? That question is becoming obsolete, because now Volkswagen is asking how to develop electronics faster with XPeng. Renault is using engineers in Shanghai to accelerate a European car. Audi is building a new electric identity with SAIC. General Motors is exporting a Buick developed in China and signing a partnership that will still exist in 2047. The most shocking thing about China's car industry is no longer that it learned how to build Western cars. It is that some of the companies that once taught China are now coming back to learn, and the next American car that shocks the world may still wear an American badge, but part of the idea behind it might begin in Shanghai.